No. Noah? Thank you. So now I'm literally going to plug those in. My volume is equal to 20 minus 2x times 25 minus 2x. Length times width times height. Now I'm going to take the drastic step, and this is not a calculator question. You're going to multiply all of those together. My suggestion would be that you multiply the x out to one of them first, or you can FOIL and then distribute out the x. I really don't care what you do, but you've got to be able to tell me what you get when you multiply those three together. Don't stare at it. Go through and get it done. Hands up when you can tell me what that expression is going to be. We'll wait for 6 of you. We've got 1. 2. 3. 4. 5. Josh?
4x minus 90x squared plus 500x.
Now, what do we do? Now ask yourself this. That's your volume, right? That's what represents your volume. Are we looking to maximize or minimize it? Which one? Max volumes. How can we see what we can do to maximize what our volume is? What do you think our next step? And if you don't have linkages correctly made with what the words in calculus are, this next step you're going to be stuck. Well,
Take the derivative, find the critical points, and find the
perfect. Take the derivative, find my critical points. So now I'm going to go through and take the derivative of b, or determine b prime. And John, what's b prime going to be?
12x squared minus 1800x plus 500.
How much?
Or 180x. Sorry.
And now, after we did that, I'm going to go through and set it equal to 0 to find my criticals, which no told us to do. Except, what can I do that's going to make this a hell of a lot easier than what you're probably trying to go through and do right now? I mean, I look at this, I'm going, holy cat. This looks very daunting. But if it's calculator free, it's that way for a reason. What can we do on this? You tell me. You tell me. What? Take out a 12. Set it equal to 0.
I didn't lose their work.
Oh. Okay. Here's why. I didn't realize. I forgot. I'm sorry. We're actually going to solve this on the calculator. So, I thought so too. I'm sorry. I'm old. Now, we're going to have you go through and do everyone. How many do you think have now signed into their calculator yet? 2. Shame on both of you. You hurt my heart. Now, what we're going to go through and do is, you're going to go into your calculator. You're going to solve this out. Now, you could solve it quadratic. Oh, no, you can't. Wait, is there an x? You could quad formula it as well. But what we're going to have you go through and do. I'm clear on. Boom goes the dynamite.
Yep.
Now, what you all are going to go through and do right now is you're going to go back. You're going to get a new doc, and we're going to graph this. You need to figure out when the derivative is going to be equal to 0. So go in, go into a new document, and what we're going to do, what is this?
What is going on?
Who is this?
No.
Get out of the scratch pad.
We're going to shame you. Who is this?
Noah.
Noah. Come on, Noah. Go over. No. What are you doing? Go down to new doc. Click no. We don't want to save anything.
Hey.
There we go. Now, go back. Stop. Go back to your home screen. We're going to make it nice and easy. Just go down here, please. Click on this. All right. Now, we're going to graph this function out. and you're looking for where it equals 0. So we're going to graph out this function. It's going to be whatever it ends up being. So go through and plug it in. Now, we're going to actually probably talk about something else that's going to happen to it in just a second. So we're going to graph this out. Now, we get one answer here. Let's do this. We might do a Zoom stupid for just a second. Do me a favor, please go into menu and go to 4 for Zoom. We're going to go back to the standard window in just a minute. Let's do this. Go to Zoom fit for A. I just want to see where that other 0 is. Because how many zeros does this equation have to have?
2.
2. Now, looking at this, there may be another 0 really far. Is this 10? It's actually going to be past 10.
Yeah.
So let's do this. Let's go into window for 4. I need to go see more to the right than I was seeing before. So I'm going to go to Windows Settings. Let's make our X max not 100. Let's make it, let's say, 50. We're going to get into Y. We wouldn't go out to 100 in just a second. Believe it or not, the Y min and max have no... Now, here you go. How many zeros do we see now? 2. So what I need you to do right now is you're going to go in, you're going to use the Calc menu. We're going to analyze the graph, which is 6, and we need to figure out where the zeros are. Actually, wait a second. So I think there's a way to find this easier, if I remember right. No, we can't. Sorry. Go to 0. Now, go over to the right-hand side and click Enter. Now, go somewhere past the first 0 and hit Enter. Go past just the first 0 and press Enter. Now, here's our problem. What's wrong with saying it's x equals 3.618? There's actually 2 things wrong with me saying it. If I write down x equals 3.68 right now, what's wrong with this? What?
You're looking for a max, and that's never mind.
That's part of, yeah. There's another one there, but what's wrong with this if I said x equals 3.68? Yeah. No, it's for a solve, so we're solving out an equation. The problem is twofold. Number 1, no. We'll do that stuff later on. What I'm going to say is this. First off, how many places do you need to give your answer to on the AP? 3. This is 2. So hover over, go to 3 places on this. Hover over the point, make the claw happen. Go back. No, not on the point. Go over. Now hit plus. Scroll over the number here.
Hit the claw.
There you go. Now hit plus. Why is it this? There we go. Now, so 3.618 is one of your answers. Go find the second answer now. We're going to discuss why you're going to have an issue in just a second. Go and find the second answer now. So go to 6. Finding another 0. And by the way, that you also need to give 3 places on. You can stop writing after 3, so press Enter. We may need to go and drag that up. But something interesting is going to happen. You drag this up, and now you're going to see, well, I'm going to say this. Stop right there, and this goes back to sometimes the algebra is going to be different than what the question requires. Why would 11.3 and change not be an acceptable answer for x? And this goes back to something where if you fell asleep during this question, you're not going to get why. What is the problem with an answer of 11.3-ish units? Hands up, please, if you can tell me what the problem is. Because this shows an overall aptitude and an awareness that we can't teach. You see it? Go back to the original. If you made this, you're cutting squares out of side length 11.3. What's the problem? What's one of your side lengths?
20 minus 2x.
Yeah, so 20 minus 2 times 11 and change makes me have a negative side length. Can that happen?
Nope.
No. So you've always got to look for both of them. So I'm going to say this. The algebra indicates that our x comes out to be approximately, and was it 681? Is that right?
681.
681. Now, you need to go through and how large should the squares be? So that's going to help us answer that. What is the resulting max volume going to be? Well, now I would actually type this. Believe it or not, the easiest way to do this is to go into your calculator, type this expression in, do a bar, and then do x equals. So go through and do, I don't care how it gets done, but go through right now. I need the answer of what the volume would be approximated, by the way. It's not exact. Notice that we didn't use an equal sign. And Mike, let us know what you get for that volume to be approximately. Go through and do it. Don't stare.
What's wrong with this? How's it wrong?
What's wrong with this?
Clear 'em.
Now, when you go through,
Yeah, you're not.
oh, wait, I think it's because wait, I can do it again? Okay, now. What we're going to go through,
No.
but he's right. That's what your volume ends up being. Now, when we do out our next question, the same process over and over again. The next question is actually one that's real world significant, especially if you look at, in oil shipments and things like that. Cylinders are very important shapes. Now, you've been asked to design a 1 liter oil-shaped can like a right circular cylinder. What dimensions will use the least material? So it's got to hold 1,000 centimeters cubed. You're looking to minimize what that is. Now, let's figure out the surface area. You have a top and a bottom. What shapes are the top and the bottom?
Circle.
How do you find the area of a circle? Hands up, please, if you can tell me how you find the area of a circle. Hands up, please, and tell me how you find the area of a circle. Seriously? Josh?
Huh?
How do you find the area of a circle?
Nah,
You're lower than that. It's gonna be Jack. No, it's Noah.
Noah? You know how to find the area of a circle? Thank you. Now, Noah, how would you find the area of both? How would you find the area of both of these circles? Which is what? 2 pi r squared. So the first thing I would go through and do is recognize that my surface area is going to be 2 pi r squared. Now, I need to figure out how long this rectangle would be, the sort of wrapper on the package. And when I'm doing this, remember, this would be the height, and this would be the length. So you do length times width, or length times height, depending on how you interpret the shape. So that would end up giving me a surface area, or a net formula of 2 pi r h. Now here's our problem. When I'm looking at this, I have to make a replacement, because we're trying to find which dimensions will use the least material. The problem that I currently have is the right half of this, the part that you're taking the derivative of. You're going to have to go through and recognize you have too many variables. How many variables are there on the right-hand side? Hands up, please, when you can tell me. How many variables are there on the right-hand side? Thomas? 2. What are they? R and H. What I'm going to do is, and by the way, which one shows up? Well, we'll say this. There's a way to solve for one in terms of the other. There's a way to solve for one in terms of the other. And it goes back to what your initial condition is. The initial condition is the volume of this needs to be 1,000 centimeters cubed. Now, when I look back at this, what I would say is, I know the volume formula as well. I go through and say my volume formula is pi r squared h. I'm going to make my substitution in. So now, instead of the volume, for this example, it would be 1,000 is equal to pi r squared h. Which variable is it easier to go through and solve for? Hands up, please, if you can tell. I'll say it this way. You have to pick one of them to get alone. It's easier because one variable shows up twice, one only shows up once. I want to make the replacement for the one that only shows up once. In this case, it ends up being the easier variable to solve for. What's the easier variable to solve for?
H.
And how would you solve for h?
Divide both sides by pi r squared.
So everywhere in this case that I see an h, I go through and replace it with pi r squared. So now I'm going to go back over to the sides and say, well, here is, instead of it being 2 pi r h, it's 2 pi r times what we got the h to be equivalent to for this question. Now I'm actually going to start simplifying out, because look at the right-hand side. Who can tell me something that's going to simplify down on the right-hand side? Seriously? Terrific. Noah?
Pi r over pi r squared would just be r squared on the denominator.
Close.
Or r on
So what is this going to become now, Noah, on the right-hand side?
2,000 divided by half.
Now, when I do this, now I've gotten this as far as we can go. And by the way, when I see this, I hope you do too, I'm going to be taking a derivative. The weaker amongst us will say this right here is a quotient rule. It's not. In reality, you should be able to recognize what's an alternate way of writing this expression that will be very easy to take the derivative of. Jake? I can bounce in and out of that notation if I know my stuff. Otherwise, again, if I'm in the wilderness, I'm in the wilderness. So, what is the derivative or the change in the surface area going to end up being? What's my change in area formula for this case? What is it to take the derivative of this? One person? Seriously? Jake? Careful. It'll be minus 2,000 r to the negative second. Now, when we get to here, I'm going to go through and I'm looking to go and what was I trying to do? Oh, I get to this. Sorry, I got to set this to be equal to 0. Now, when I do this out, here's another one. You actually could, yeah, this one we need the calculator for as well. Go through right now, please graph this and tell me where this is going to equal 0. Now you could use an, please when you graph it, understand it's not an r, it's an x. So go into your calcs right now. You may need to modify your window because you need to see what both of the answers or intercepts are going to be. And maybe something really cool will happen with one of them. But go through and graph this out. Let's see what we get. We were talking about this too in the other section, or as a math department the other day. They're going, these calculators, we really don't need them. And I can't more vehemently disagree. We need them more than ever. Okay. Looks like. Now, I'm going to say this. I'm looking at this person's graph right here, and I'm going to bounce between graphs so you'll see this. I'm looking at this. Where are there two answers? I actually think this is the case. There's an answer over here and an answer over here. Why is it so great that there's an answer over here? Hands up, please, if you can tell me. Why would it be outstanding to all this? My life is easier. What? Perfect. You can't have a negative value, so I'm going to focus in on what's happening over here. And if I did just a regular Zoom stupid, go back to your regular Zoom window, and whomever this is has that showing already. This is already there. So find out what this 0 is right now. Go through right now, please, and figure out what that 0 ends up being. Go through right now and figure out what that 0 ends up being. Find your intersection. All of you. Do not find it. Noah again. It is. You're our showcase model today. I even hit the names before.
Sorry, my bad.
No, it's fine. All of you go through and do it. We'll pick on someone new. I'll shuffle them up. Find out what that other intersection is going to be. This person must have done a slightly different Zoom. But they're still going to go through and figure out what it is. Look at this. Now, why am I outraged and offended by what they're giving me right now?
2 places.
2 places. Don't be basic. Go hover over it and hit plus. Do the claw, hit plus. Now, hit minus to show less. So, here's what you need to understand then. When we do this out, we get an answer of, oh, sorry, I did this out algebraically. I'm sorry.
No.
Sorry. In any case, we got an answer of the same thing, which was what, 5.419, is that right? Okay. So, you could have done this algebraically, I'm sorry. Actually, I'll make a note of it. So my radius would be that amount. How can I figure out what the height is? Hands up, please, if you can tell me how I know what my height is going to be about-ish. Yeah? Don't forget. Stop up here. So now you get that. That's your radius and that's your height. Here's something that you should get in the habit of showing. Is this a maximization or a minimization? Minimization. Don't assume, because the AP could give you multiple values or a test or something that doesn't work. Now, your homework is your math Excel. What day, by the way, on there are we having our quiz on the next time yet?
It's always
Every time. Always.
That's at the end of the unit.
He just lies to us.
I know.
He tries to get us like, I don't like it quick. He's trying to get you.
I know. Bad.
What's today's date?
I don't know, he's like, oh, you want to rock? I thought they were trying to get
Coming up soon. Not next class, but the one after.
What is that?
Dive into fun and learning.
It was bad.
Who you?
I'm not going to sugarcoat it.